Good morning, afternoon, evening, grade 11s. Now, how many of you are actually watching this? Let me know. It's just a backup because, I want to make sure that we got everything as best as possible always. So we're going to see how this streaming from one campus to the other goes. But yeah, as I said, hoping to see each of you as much as possible. So anyway, but let's see. At the very least, it's a good practice run for our lesson, right? So we're doing number patterns. And for number patterns, we're looking at one type of pattern, and those are quadratic sequences. Now, a sequence is just a pattern, really. So we've got quadratic sequences. Well, I guess we should look at more than one. And when I say quadratic, does anything come to mind? Quadratic, we've come across it already. I mean, is there any type of shape that you've seen that's, quadratic? And when you think about that parabola, then what power of x are you thinking? Is it x squared, x cubed, just x? Well, if you're thinking x squared, and so we had a general way of writing our parabolas. So we always had like y equals or f of x equals. Now we looked at turning point form and we looked at intercept form, which we didn't use that much. But our general form was kind of that ax squared plus bx plus c. So the same is going to apply here. Just instead of y, our output is tn. That's the output. And our inputs are going to be n. So input n, output tn, as opposed to input x, output y. But similar otherwise, we got an squared, where's our squared, plus bn plus c. Okay, so that's our general form for any quadratic sequence. So there it is, ready to go. Now, how's that going to help us? Well, sometimes it's useful. Just jot down things that we know and let's see where it takes us. So we got quadratic has got the squared part. If we thought of a picture, we think of parabolas. We're not going to be drawing parabolas. I'm sorry. But you can still think of the happy and sad parabolas. So we got this and we're going, okay, let's take an example. I'm going to give you an example of a quadratic sequence and let's see how we know that it's quadratic. So my example here is the sequence goes 7, 10, 15, 22, 31, 42, and so it's going to carry on. Now, from the 7 on this side, I don't know if this is working, but let's see, from the 7 on this side all the way across to like the 42 on this side, we're not increasing by the same amount, are we? It's not linear. It's not like a straight line where it's just going up by the same amount, is it? Well, let's just have a look here. So how would we work that out? Well, we'd say, from 7 to 10, we've increased by 3. Okay, and from 10 to 15, we've increased by 5. Okay, so it's not linear, but let's just keep going. And so from 15 to 22, but it looks like another pattern's emerging. From 22 to 31, we've increased by 9. So from 7 to 10, increased by 3. From 10 to 15 by 5. From 15 to 22 by 7. 3, 5, 7, 9. Let's just take a swing at it. Is this going to be 11? Well, from 31 to... Hey, look at that. So it looks like there's another, like a hidden pattern. So if we looked at this part here, and let's say, this is a difference, right? But this we can call the first difference. So the difference we're looking at is, the first difference is 3, 5, 7. It keeps changing. But what happens if we were to look at maybe a second difference? So we looked at the difference of the differences. Is it cool? I don't know, right? So let's say we did that, and so let's see what happens. What's the difference from 3 to 5? Well, that's 2. What's the difference from 5 to 7? Well, that's also 2. Looks like the difference is always 2, is it? Yeah. So this one's linear. The first difference is linear. It's going up by the same amount each time. In other words, that difference, that second difference, is constant. Okay, so we got a few things going on. So, seems interesting enough. And maybe for reference, let's say, maybe this first term could be interesting. So I'm just going to put it here to say the first term here is 7. I don't know. Let's trying to pick out some of the interesting bits here. So we've got the first term, we've got this first difference, we've got the second difference. Okay, so that doesn't help us because, how does this translate into a formula? It would be nice if we could get what's the formula of this sequence given, right? The quadratic sequence given. That's clearly where we must be going. So let's try this out. So let's say that we know this. Let's start with this as our starting point and say, okay, so let's pause on that example. We'll come back to it. And go, we know that any sequence looks like that. An squared plus bn plus c, any quadratic sequence. And let's look at the first few terms of this in this general way. So what I mean by that is, let's look at what is the first term, t1. How are we going to work out what it is? Well, let's substitute, right? N is 1, so wherever we see an n, let's put a 1. So we've got a 1 squared, always put it in brackets, b1 plus c. I feel like I'm doing the grade 8 skills paper. So we've substituted, and we've got 1 squared is 1, so 1 times a is a, not a squared, right? 1 times b is b, and c is c. So our first term's a plus b plus c. So in our general form, let's go, we've got a plus b plus c. That's our first term. Remember earlier I said maybe let's just make a note of this. I'm going to write first term over here. That's our first term. Cool. Very cool, right? Okay, let's work out what our second term is. Go for it. Well, we've got a, we're going to substitute a 2 squared plus b, 2 because n is 2 plus c. There's no n to do with the c. So 2 squared is 4, so this is 4a. B times 2 is 2b. Yeah, chocolate's all right. Plus c. Okay, so our second term is 4a plus 2b plus c. Okay, let's work out our third term. And we'll pause after that. So a 3 squared plus b 3 plus c equals 3 squared. Okay, I think we're getting into the swing of it, right? 3 plus 3b plus c. So that's our third term. So now for any quadratic sequence, it goes a plus b plus c, 4a plus 2b plus c, 9a plus 3b plus c. I don't want to scroll down because we don't need to see the working. Now, that is only so helpful because what is our sequence? 7, 10, 15. So a plus b plus c is 7. This is 10. This is 15. If we were given an example. What can we do though? What feels like we could do? What have we looked at so far that could maybe help us? We looked at those differences. So let's say, what's the difference from that to that? So in other words, what's this whole second term minus this whole first term? Well, to get from a to 4a, we need to add 3a. In other words, 4a minus a is 3a. To get from b to 2b, we're going to need to add a b. So 2b minus b is b. Cool? To get from c to c, we don't have to add anything. So c minus c is 0. Okay? Let's now look at this difference. 4a to 9a, well, that's 5a. 2b to 3b, that's plus b. C to c, we don't have to add anything. So that's our first difference. This is what we're looking at to start with because it seemed interesting enough. That's how we dealt with patterns before. So there's our first difference. Okay, so what do you think we're going to do for our next bit? Well, yeah, let's have a look at our second difference. So our second difference. And let's find a nice color here, yellow. Cool. So our second difference, which is always going to be the same, remember? So we don't have to keep working it all out. Whatever this one is, it's always going to be this. So what's to get from there to there? From 3a plus b to 5a plus b. Well, we just need to add 2a. B's, no, nothing. So 5a minus 3a is 2a. B minus b is 0. Now, I know where we're going, so I'm excited by this. And you're looking at it and it looks even more complicated, probably. But they're the three things you need to know for quadratic sequences. The first term is a plus b plus c. The first difference is 3a plus b. And the second difference is always going to be 2a. So there are three things we know. Let's actually just jot them. Let's jot down all the things then that we know about quadratic sequences. We know that any term is an squared plus bn plus, we'll get there, right? Equals an squared plus bn plus c. Cool. That's useful. We know that the first term, the first term is a plus b plus c. So let's put that in. A plus 36 seems a bit big. 18, there. The first term is a plus b plus c. So these are the bits that, because we're going to just practice quite a few of these, you're just going to remember these. You could always go back to constructing it, but you'll see when we do the first two examples that we always just use these. So first term is that. The first difference is, and let's line that up nicely, it's going to be, 3a plus b, right? 3a plus b. And the second difference, let's get that ready. The second difference equals 2a. So these are the bits of information that we found out so far. So there it is. There is quadratic sequences in a nutshell. Tn equals an squared plus bn plus c. First term's a plus b plus c. First difference is 3a plus b, and the second difference is 2a. Let's see how is that going to help us with what we were given. So let's go back to our example of 7, 10, 15, 22, etc. and see how does that help us get a formula for it. So if we're given, let's do it over here. In fact, I'm going to move these so that we've got them. Copy, and let's have this here. Cool. So our example was 7, 10, 15, 22, 31, 42. And we worked out the first difference was 3. We need to do this first difference just for those, and then go, let's get to our second difference was 2. Okay, so how's this going to help us? Well, the second difference is 2a. So if the second difference is 2a, and our second difference is 2, well, we know that a must be 1, right? Seems reasonable to me. First difference is 3a plus b. So 3a plus b. So 3a plus b. But our second difference we worked out, our first difference, at least this part here, was 3. Remember, the first difference changes, but this is kind of the first difference, is 3. So if that's 3 and a is 1, then 3 times 1 plus b equals 3. So 3 plus b equals 3, so b equals 0, right? 3 plus nothing gives you 3. Okay, so far we've got a equals 1, b equals 0. All that remains to be found out is what c is. Then we've got our final formula. Well, the first term is a plus b plus c. So let's do this and say, well, a plus b plus c is our first term. First term was 7. There it is there. I like highlighting it like that. So that's 7. A we worked out was 1, was it? Yeah. B was 0. C we don't know yet. So 1 plus C equals 7. C equals 6. So C equals 6. So therefore, we've got our final formula. Tn equals an squared plus bn plus c. Well, let's make that look a little bit neater. 1n squared we'd normally write n squared. 0n we wouldn't normally write, plus 6. Okay, so that's our strategy. We just need these bits of information here. And we can do it for anything. So let's do another quick example, because really it comes out quite quickly once we know how to do them. So we got 5, that's a great 5, 5, 12, 23, 38, 57. I tell you, it is a quadratic sequence. It is going to carry on in the same fashion. Determine the equation of the quadratic sequence. Determine the formula. Okay, cool. So we run through it. We know that we need to find this first difference. 7, this goes up to 11. And then we don't need to work out after that, because we're going to go, cool, what's our second difference? 7 to 11 is 4. So 2a equals 4, a equals 2. Easy enough, right? Then we said this 7 over here, 3a plus b. We're going to work with it enough times that you're going to go, oh, what was it again? For the first bit, 3a plus b. Okay, cool, 3a plus b. So 3a plus b equals 7. We know a is 2. So in other words, 6 plus b equals 7. So b must be 1. Great stuff. Last bit. Something about that first term. Well, we could really go back and substitute if we wanted to, but you're going to work with this in so many examples. You're going to look back and go, what was it again? A plus b plus c. Great stuff. So a plus b plus c, where are we? A plus b plus c equals that first term, which is 5. Cool. We know what a is. A is 2. B is 1. There it is there. Plus c equals 5. 3 plus c equals 5. C equals 2. But it didn't ask us what a, b, and c were. It said, what's the general equation? So Tn equals an squared plus bn plus c. Done. There we are. So for the first bit, you'll be going back and checking your notes, but it's all in that bit there. Okay, that was quite something, right? Goodbye.